Hello everyone and welcome to this mini lecture series on a case against evolution. We're going to do one lesson today and then one lesson tomorrow. On Friday we are going to have a quiz over a case against evolution. I would recommend, if you wanted to, maybe read the quiz now. That way while I'm lecturing here on a case against evolution, you can kind of pick up on some of the things your quiz was talking about. And maybe you can answer some of the questions as we go along. That'd be a pretty smart thing to do. So, a case against evolution. Is evolution as airtight as many people think it is? Well, I guess we're going to find out. But to find out, we have to start with the origins of evolution. How did we arrive at the place where public schools, every public school in just about the entire world, that they are teaching evolutionary principles? How do we arrive here? It started with Charles Darwin. Charles Darwin writes this book. The book is called The Origin of Species. Charles Darwin was actually a pretty prolific writer. He wrote a lot of different things. He wrote The Descent of Man, which is another book he writes. And he wrote it while aboard the HMS Beagle, observing the Pacific Ocean islands. And while he is exploring these islands, he's given a book by the ship's captain. And this book is called The Principles of Geology. It was a book written by Charles Lyell, and it influenced Darwin. And the Principles of Geology expounded on a principle called uniformitarianism. And you're going to want to write this beside uniformitarianism. Uniformitarianism said that the Earth changes very, very slowly, if at all. You see, Charles Darwin said the same processes happening today are the ones that were happening 1 billion years ago. Now, that's a pretty incredible thing to assert. I mean, consider that a lot of things changed just with something very small. I mean, right now, I understand that this doesn't necessarily have to deal with geology, but right now we have the coronavirus. It's changed how we do school. And to say things don't really change all that much is pretty bold, but it influenced Darwin. And Darwin used his position in academics to be able to influence others. And that's kind of how we got here today. Now let's talk evolution for a second. On a car ride to and from Pennsylvania, I actually took a course from Yale University. Very cool. Everybody wants to go to Yale. Hardly anybody does, right? I wasn't enrolled in Yale. It was actually a free course that they put online. Very cool. And here's what the PhD professor said. He said, evolution happens through a combination of 3 different forces. He says the first force is geographical isolation. He says organisms get separated, and then they have time to become different. That kind of makes sense, right? So, if, let's say, you have a sibling, and you two get separated, and you remember each other, right? And 100 years down the line, your families meet for the first time. Would they really know all that much about each other? Probably not. They probably wouldn't even recognize each other. You might have told your kids, hey, you know, I had this sibling, he's kind of cool, and then they probably didn't tell their kids, and then, because things change over generations. We kind of know that. So, geographical isolation, here's another one, natural selection, the survival of the fittest in a species. Darwin actually said the one who changes the most. Now, natural selection selects the most fit to survive. I think the last time I taught this, I used the island illustration. If we got dropped off on an island somewhere, who would survive? It'd probably be the fastest of us, the smartest of us, etc. And that kind of makes sense too. The strongest survive. Okay, I can get with that. A genetic mutation, a change in the genetic code. And this professor that I was listening to at Yale, he said the average person has 4 or 5 genes that have mutated from one generation to the next. And as it turns out, half of those mutations turn out to be harmful for you. Well, that's not very good, right? So odds are I inherited from my mom and my dad these different genes, and the likelihood is that about 2 of them are going to hurt me. Well, thanks, Mom and Dad, right? But a change in genetic code. And, well, it's kind of hard to tell what kind of mutations help people. We're going to try and explain that in a second. And they say a combination of these things lead to evolution over time. And here are 4 examples that they give. In fact, these are some of the same examples. 3 of them on this list are examples that this Yale professor gave in classes I was watching. I mean, you can even look at it yourself if you'd like. You can go to Yale Biology Courses Free. And you can see I went to the website, and this was under evolution. There you go. Evolution, evolutionary biology. It was taught by this guy here. I used my phone, so I don't know exactly how to get to where I was. But anyway, there it is, sessions, and all these videos I watched, and he goes and he starts talking yada 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 about all these different examples of evolution. He starts with Darwin's finches, and he says the finches had different size beaks, they had different sizes of the finches, and Darwin witnessed this over just a couple of generations as food supplies dwindled and changed. And so things evolved, things change. And I'm like, maybe evolution has a point. And then you start thinking about it. Did those changes lead to something better? Yeah. Did those changes lead to something genetically improved? And the answer is no. And in every one of these cases, genetically, there was nothing new. And we can look at the pepper moths. Peppered moths were in England in the 1800s. And as England hit the Industrial Revolution, the skies got a little darker. Things got covered in soot and in a lot of the pollution. And the moths that were dark in color were originally picked off, right? They were very easily spotted on a white background. But now, as things got darker and more black, the black moths blended in, and the white moths stood out. And so the white moths started dying, so the black ones took over. And then when they cleaned up the city, the black ones started dying, the white ones took over. And it's evolution. They're changing their color. But does a color change that's already in the genetic code indicate that a genetic code is improving? Here's another one. Antibiotic-resistant bacteria. He said, this Yale professor said, there's no better evidence in antibiotic-resistant bacteria. In fact, MRSA, methicillin-resistant Streptococcus aureus, is something that hospitals all over the world are fighting. In fact, it kills about 1 out of every 16 people who go into the hospital for surgery. They don't even go in with this disease. They come out with it, and it can kill them. That's incredible. And antibiotics don't treat it. And they don't treat it because MRSA evolved. Oh, does that prove evolution? No. And you know why? Because MRSA actually didn't evolve to become better. It evolved to become worse. How does that work? It actually lost some of the functions that made it a great bacterium and made it into a really simple version of it. For instance, some antibiotics target the cell wall and break the cell wall to kill the bacteria. Well, MRSA lost its cell wall. And then some antibiotics unlink DNA and cause it to be ripped apart to kill the bacteria. Well, MRSA just lost its ability to link its DNA. That doesn't sound like MRSA's getting too much better, right? It sounds like MRSA's getting a whole lot worse. Here's another one, pesticide-resistant drugs, or bugs. We started spraying pesticides everywhere, and now all of a sudden these bugs that are emerging are resistant to pesticides. But we found out they're not as good bugs as the ones that were there before. Why? Because they lost genetic information. All of these things lost genetic information over time. That defies evolutions, making them not good examples. Because each one lost something, and evolution requires the gaining of genetic material. The only examples of evolution we have are all bad examples. That's not very good for evolution. What can change bring? And we've learned that natural selection, among other things, genetic drift, genetic isolation, and mutations can decrease genetic information. And sometimes decreasing something makes it a little bit better. It can allow organisms to survive better. It can act as a selector of what's already there. But natural selection cannot create anything new. It has never been shown to increase genetic information. It can never act as an originator. And this portion of natural selection supports creationism because it supports the fact that God made a stunning amount of variety, and over time, the variety was lost and things changed. So you might have had Noah take a wolf onto the ark, and that wolf might have became some of the things that we see today, various species of wolves and maybe even some domesticated dogs. But all that genetic information has been lost. You know what the stupidest dog is? It's a corgi. I kind of like corgis. But they actually have the least genetic information out of any dog. Why? Because they're the one natural selection has had the most effect on. That makes corgis an agent of taking down evolution. That's kind of amazing. Now we're going to go through evidences against evolution. And I'm going to end pretty soon. Evidences against evolution. The first evidence is that evolution cannot be a theory because a theory must have the following four qualifications. Evolutionism doesn't have that. Therefore, it can't be a theory. Number one, it must be falsifiable. Okay? If you have something in science, you want to falsify it, you want to prove it wrong. You can't really prove evolution wrong because you can't prove something that's happened a long time ago. And so it can't be falsifiable. Neither can creation. You can't really say there isn't a God and prove that. Why? Because it's not falsifiable. Here's another one. It must make predictions. How can evolutionism make predictions? We can't predict what natural selection is going to do. Theories must be repeatable. Well, our history sure isn't repeatable, right? And lastly, it must be as simple as possible. We're finding out more and more that evolution is so massively complex. As we run DNA sequences, we find out evolutionists say some things are related to other things that they had no clue. You know, wait, hippos are related to a horse? How? They have to revise their theory? And it's not very simple. And that's a principle called Occam's razor, something as simple as possible. For instance, if you had a nail in your car, you would say, oh, I probably ran over the nail, instead of some student like, ha 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 ha, and nailed a nail right into your car and laughed, right? We'll be right back with our next video.